Hi, we're adding and subtracting numbers in scientific notation. So, like you mentioned in the video, if they have matching exponents, so this 10 is our base and 15 is our exponent, and then the second one, 10 is our base and 15 is our exponent again. That's the only situation in which you can just do the subtraction. So, since they are the same exponent, we're going to go ahead and do the subtraction. 7.8 minus 6.3 would be 1.5. We can use a calculator. So we get 1.5 times 10 to the power of 15. Okay, these ones also have the same exponent. They both have the exponent of 9, so we're going to do the same thing. 5.4 minus 3.2 would be 2.2 times 10 to the power of 9. Adding them, these ones do not have the same exponent. This one has a 3 and this one has a 2. So what we're going to do is we're going to write these out in standard form and then add them and then convert them back into scientific notation. It has a hint here. Since the exponents are different, change the number into standard form, then perform the calculation. Don't forget to change the answer back in scientific notation. So 7.2 times 10 to the power of 3, 7.2 times 10 to the power of 3. This exponent tells us to move the decimal 3 times, and it's positive, so we're going to move it to the right 3 times. So if I did that, my decimal was once here, moving 1, 2, 3 places over. So I get 7,200. So now that that's in standard form, I'm just going to write it over here so that I can add up my other one pretty quickly. Okay, the other one is 2.2 times 10 to the power of 2. And we'll write that in standard form. So we'll take the 2.2, we'll move it, the decimal to the right twice. And now we get 220. So we just took the decimal and moved it twice because the exponent is a positive 2. So we got 7,200 plus 220. Add them up. We get 7,420. To write this in scientific notation, we're going to keep our digits of value, put our decimal right after the first digit of value, and we're going to multiply by base 10, and then we think how many times did we move the decimal from 7,420 to 7.42. We moved it 1, 2, 3 places. So we get 7.42 times 10 to the power of 3. Okay, different exponents, so let's turn them into standard form. We've got 1.1 times 10 to the power of 4. Okay, so we're going to move this decimal to the right 4 times. Okay, so now I have 1, 2, 3, 4 places. Move my decimal to the right. It would be right here. And I filled in those empty spaces with zeros. So now my answer in standard form is 11,000. Let's figure out our other one in standard form. So we have 9.8 times 10 squared, or 10 to the power of 2. 9.8 times 10 to the power of 2. And then we're just going to take our numbers, 9, 8. Our decimal was here. We're going to move it 1, 2 times, fill in that empty space with 0. So we get 980. If we add 11,000 and 980 together, we get 11,980. And then we have to turn that number back into scientific notation. So I keep my digits of value 1.198 times 10. And in order to get from this decimal point back over to here, we would have moved the decimal 4 times. So I get 1.198 times 10 to the power of 4. Okay, 2.4 times 10 to the power of 4 times 10 to the power of 4. So we're going to move the decimal over 4 times. That's where my decimal was. So now I'm just going to count this 1, 2, 3, 4. And I get 24,000 in standard form. Now I'll do the other one. 3.2 times 10 to the power of 3. So 3.2. My decimal is here. I'm going to move it 1, 2, 3. 1, 2, 3. I get 3,200. Okay, now I add up these numbers. 0, 0, 2, 7, 2. Keep my digits of value. I put a decimal after the first digit of value. Times 10. And how many digits I have to move this decimal? 1, 2. I would have to move it 1, 2, 3, 4 times. So I get 2.72 times 10 to the power of 4. And this one, they have the same exponents, 10 to the power of 12. So we can just add them together. 3.7 plus 2.1 would be 5.8 times 10 to the power of 12. Subtracting them, they have different digit or different exponents. So let's write them in standard form and subtract and then convert it back into scientific notation. So we've got 2.5 times 10 to the power of 4. Okay, so we're moving our decimal 4 places to the right. Okay, now I have 4 digits after where the decimal was originally. And I'm going to remember this is a subtraction problem, not an addition problem. Minus 6.8 times 10 to the power of 2. 6 would give us 680. Okay, I'm going to subtract them. Remember when you're subtracting, go 0 minus 0 is 0. And remember the thing, bottom, bigger, borrow. So if the bottom number is bigger than the top number, you're going to have to borrow. Can't borrow from 0. We're going to borrow from the 5. We have to give to our nearest neighbor first. Cross that out, make it 10, borrowing again. Okay, 10 minus 5 is 5. 9 minus 6 is 3. Bring down the 4, bring down the 2. We get 24,350. We keep our digits of value. We put a decimal after the first digit of value. We multiply by base 10. And we count how many places we'd have to move the decimal to the right. We'd have to move it 1, 2, 3, 4. So we get 2.435 times 10 to, oops, what did I do wrong? 2.435. Okay, what did I do wrong? Let's see. 2.5 times 10 to the power of 4. 2.5. 1, 2, 3, 4. Okay. 6.8 times 10 to the power of 2. 680. 25. Oh, I did 650. That's where my problem was. Great. So this is a 2. And this is a 2. So 2.432 times 10 to the power of 4. Not 3. 4. Come on, let me type. And we're on to new things. The last lesson. Exciting.